Welcome back to the Scotti-BYTE channel, and this is Scott. So today I'm going to talk a little bit about SATA docking stations. A SATA docking station is an integral tool for the home lab. The Scotti USB 3.0 to SATA external hard drive lay-flat docking station is for 2.5-inch and 3.5-inch hard drives and SSDs. The Scotti USB 3.0 M.2 tool-free enclosure is for M.2 NVMe and M.2 SATA devices, and I use both in my home lab. So both devices are under $30 and they support USB attached SCSI, otherwise known as UASP, which is up to 70% faster than the USB bulk only transport protocol. So UASP is faster because it supports parallel processing of multiple outstanding queued requests and even out of order processing, unlike BOT, which is extremely serial in nature. So the 3.5, 2.5 inch device is a Type A USB device, and it's USB 3.0. And you might ask, why did I not go for USB 3.1? And it's because this is viewed as a maintenance device only. My idea is to be able to put disks in this device and perform maintenance on them and perhaps move them to another device. So it might be an initial install, it could be modifying a partition, it could be using DD to back up a particular partition. And then the second device that I own is much smaller because this isn't really to scale, and it's a USB M.2 NVMe, and it also takes M.2 SATA devices, which are up to the 2280 form factor, which are the longer sticks, and it has a USB-C plug on the back, and it does do the USB 3.1 10 megabit interface. And I find it valuable for performing backups and resizing of partitions and that sort of thing. So sometimes it's really handy to have both devices around, and it's also a great way to check a drive that you're not sure may be working, and yet you're able to perform full diagnostics on it. The Scotti USB 3.0 docking station is a valuable device in my home lab, and I have it connected via USB 3.0 to a Type A port on my desktop computer. And the fact that it's a lay-flat format allows me to plug in a drive really easily. In this case today, I'm going to repurpose a number of these Western Digital 10 terabyte red drives that just came off of my one of my NAS units, and I'm going to repurpose them for use in another project. So here we are in the G-Parted tool, which is the graphical version of the parted command line tool that I've used on the channel before to create partition tables and partitions on drives and format them. But here we're using the GUI partition tool called G-Parted. The drive that you're seeing right here is my main system disk, which is an NVMe drive, and it has an EFI boot partition and the Linux root partition. In addition to that drive, I also have a drive SDA down here, which is a spinning drive, and that beep you just heard was that I had turned the power on the docking station, and by so doing, it discovered the new drive. And if I come up here to the G-Parted menu and click Refresh Drives and go over here again, we now see the new drive SDC, which is the 10 terabyte drive with the formatted capacity of 9.1 terabytes. So now it says that it is an unallocated drive. Of course, I can come up here and say create a new, and it says there's no partition table on this drive. Well, this thing was part of a RAID set, so I can say create partition table. And then probably, since it's such a large drive, I want to create a GUID partition table, which is GPT. And you see there's a lot of options here that we can create all kinds of partition tables. The most familiar one, of course, would be the MS-DOS or FAT partition table, and the GPT, which is the GUID partition table. So we go ahead and do an apply on that. It creates the partition table. At that point, we can say create a new partition, and we can create it smaller, larger. We'll create it as a primary partition, and we'll allocate the entire size of the disk, and all I have to do is an add. Now, it hasn't actually written that partition yet, so I have to go up here and click the Apply All Operations button, and once I do that apply, it will go through the process of creating the partition and also formatting it. And that should take just a minute here. It says it's formatting partition /dev/SDC1, which makes it basically the third disk device on the system and the first partition. So there we go. We now have an ext1 partition, and it left 1 megabyte unformatted, which is pretty typical when you tell it to use the maximum size of the disk. So gparted is crazy user-friendly, and now that I created that partition and it formatted it, it goes ahead and shows up under my file manager under devices, and it says 10 terabyte volume. And of course, all we see in this is the lost and found. So by default, this is going to be formatted for the system user. And if I try to go out here and create a folder or a document, that's grayed out simply because I don't own this device. I'd have to own the mount point in order to be able to write to it, or I'd have to use the sudo command. Since I happen to be using Nemo as my file manager, my right-click menu has an Open as Root option, and if I type in my sudo password, it goes ahead and opens it as the root user. And now that that's the case, I'm able to go off and create documents in this folder. So as long as we're on a roll here, here's the sovereign enclosure for the M.2 NVMe and M.2 SATA devices, and it simply has a little turn on the back of it because it is a toolless case. If I open it up, you can see that there is an NVMe drive in there. In this particular case, it is a 512 gigabyte NVMe disk. Now we'll plug in the NVMe enclosure here. And with any luck, it'll be recognized shortly. And that's what that beep was there. So we can come over here, and we don't yet see the drive. But if we come over here and do a refresh drives, then we should see it in this list. And there it is. It shows up as SDE. Now notice it did not show up as an NVMe drive. And the reason for that is because it's plugged into that enclosure, and the enclosure recognizes it as a USB drive instead. So in looking at this particular drive, you can see that it is a Linux drive. It has grub on it, and it has an ext4 partition, and it has an LVM on it. And so this particular drive happens to be for an Ubuntu server that I had. So let's mount that SDC1 drive as bulk storage. And in order to do that, we're going to do a sudo make dir /mount/ we'll just call this thing bulk for bulk storage. And then we're going to do a sudo mount /dev /sd1 actually it's going to be SDC1 there we go /mnt /bulk, and it goes ahead and mounts that. And so if I do an ls of /mnt/bulk, there is that particular device. So now let's go ahead and do a backup of that device. And what I'm going to do is I'm going to do a dd command, and the particular dd command I'm going to use will look like this: /mnt/bulk/bz2. So what we're doing is we're using the dd command, which is a block copy command in Linux. We're saying the input file is /dev/sde. So SDE is the latest drive that we plugged in, and that is the NVMe in the enclosure. And then we're piping it over to bzip2, which is an open source compression program. And then it is writing it out to /mnt/bulk backup.bz2. And of course we get permission denied. So due to the magic of live video, of course you always end up making a few errors. And so I came back and I did a sudo su to make myself root, because I didn't own the mount point and didn't own the drive. So therefore, after making myself root, I'm able to do the block copy command in Linux, which is dd. if is the input file, which is /dev/sde, which is the NVMe disk drive in the NVMe enclosure. I do a status equals progress to let us know how far it's gone. And I pipe the output over to the open source compression program, bzip2, and I redirect the output over to our mount point, which is /mnt/bulk/backup.bz2. And when I hit enter, it will go ahead and start the copy command, and we should see that entire drive copy itself to a compression file. So it will be a 512 gigabyte drive that is compressing itself into a file on our 10 terabyte drive. Well, it looks like our image of the 512 gigabyte NVMe drive has completed, and it looks to me like it wrote out 477 gigabytes compressed. Now, that being said, it does make an image of everything on the drive itself. And if we do a long listing of the resulting file, it looks like it actually did compress it down quite a bit. Looks like we have around, let's see, 705, 003, 459. So it looks like 237 gigabytes is what it compressed it down to, which is actually pretty decent. So in summary, I advocate the use of a USB SATA docking station as a device helpful in creating and moving drive images from one device to another. I own both devices featured in this video, and they're available in my Amazon Associates storefront, which is linked in the video description. And should you buy from there, I would get a small amount of money back from Amazon, just as a way of supporting the channel. So both devices provide an easy means to create, modify, and copy files and partitions between devices at a low cost, and for that reason I really value them. Anyway, that's it for today. Please subscribe and like the channel, and don't forget to hit that notification bell, and we'll see you next time.